Today I will be demonstrating my project which I made for SEAI. So that is AquaGuard AI, which follows SDG 6, which is clean water. And this project is designed to monitor the water quality using LLM and using machine learning models. We have certain parameters like pH, chloride, sulfates, and some residuals. And there are a variety of parameters like this to monitor the water quality. There are some threshold. For example, if pH crosses greater than 7, the water is too base. And if the pH is very low, which means the water is too acidic. So for each of these parameters, there are different threshold limits where clean water should have a certain threshold limit. So we trained a machine learning model, that is the history gradient boosting regressor model, which is a model from scikit-learn library, and we served the model using a FastAPI wrapper. So this FastAPI will listen for the input, and this serves the model as an endpoint. So as we send the parameters as the input to the model, it will predict the water quality and return the quality score index. And when the Gen AI and Agentic AI infusion, in our project, we created an agent. So what it does is the machine learning model will give an index score. So with the help of that score, this agent is predefined with an system prompt. So it knows the correct threshold for the clean water, and it knows the clear difference between the clean and the impure water. So based on the predicted value, this Gen AI agentic layer will translate those numerical scores into a human readable report. So it just turns a raw numerical value into an interpretable insight, which can be read by any non-technical users. If you just see the numerical value, it doesn't give any meaning, right? Like if you are a person in that field, mean okay, this threshold is for this clean water, this threshold is for impure water. But if you're a non-technical person, so clear, readable reports are more, useful, and impact increase the accessibility of technical ML outputs for non-technical stakeholders. Example, local health officials, farmers. So they are not familiar with this numerical data. So in order for numerical data, we create a report and we give to them. So that's the agentic layer. Then containerization. So this is the code base of my project, as you can see. So this is the entire code base of my project. This is my train.py. As you can see, I have imported the history gradient boost regressor model, and I use the dataset. Actually, I cloned this entire repository from GitHub and fine-tuned it based on my requirement. And this is the instructions for our SEA. So I followed each and every step. So after completing my entire code base, I used Docker for containerizing the application. So this is my Docker currently running. So I already built an image for this application. I use Docker build command to build this image. As you can see, AquaGuard AI. So this image is built and pushed to the Docker Hub. And I also shared the Docker Hub in the document which I made, and also the GitHub link for this project. Now I'm going to use the Docker run command to start this container. So this is my command prompt. So this command Docker run, and the name of the container image is AquaGuard AI, and I need this container to be served in this particular port number. And as I say, I used the large language model. So the large language model which I used is around 8 billion parameters. And in my hardware, running an 8 billion parameter is difficult. So I used an cloud-based LLM provider. So Groq is one of the well-known inference servers. They provide variety of models. As you can see, they provide a variety of models from Meta, Groq itself having their own proprietary model. And from OpenAI, they have open weights. I think GPT-OS is an open source model which is released by OpenAI. Whisper 3 is an audio transcribing model. So there are a variety of models where you can play around. And also they give the code snippet or the SDK to import, plug and play to our application and use these models. Likewise, I imported this model So for running this application for the container, we need to specify the Groq API key, where I obtained from the Groq site from the API keys. I generated the API key here. Now I'm going to run this container. See what happens. Conflict already in use. Oh, I think already my container is in use. Wait a second, let me spin it again. Yeah, actually my container is already in use. So now let me open my browser and go to the specific port number of my Docker. Here we can see the port of my application which are running. Yeah, now this application is running through our container, not via any local host. See, this is the only terminal which is running our Docker. So this 8501 is the port number which is being served by our container. Now let's see how it works. So this is the um, default threshold of my application. So this is slider where you can adjust the pH level, adjust the dissolved solids. This is called a TDS, total dissolved solids. So these are some heavy impurities which you can find in the water, and chlorine residuals and contaminant trace. So I'm going to set this pH level to 0, which means the water is so acidic, and dissolved component to somewhat like 3, chlorine residuals somewhat like 5, and contaminant to 6. Now let's give this technical analysis. So what happens here is, if I give this technical analysis, these parameters will be inferenced by our machine learning model. I mean, this particular machine learning model got inferenced, right? And where is the model? Yeah, this model get inferenced and it will predict an score. Wait, I will show you live. Now you can see this is the score which is given by our machine learning model. This is the quality index score. Based on these parameters which we gave, it gave an prediction. As I said, the lower the pH level, more acidic the water will get. So see, the pH level is this is the reason. So this is the explainable AI where our LLM gave an explanation for this particular index score. The pH level is extremely acidic, possessing risk to aquatic life infrastructure. High TDS, so this TDS is very high for water. High TDS indicates high mineral content, potentially affecting taste and equipment. Evaluated chlorine levels. It may cause skin and eye irritation and especially respiratory issues. So these are the safety limits for each of the parameter. See, if the score, if this score is between 7 and 10, which is considered as safe. If the score lies between 4 and 6.9, it will give caution. And if the predicted score is below 4, then the water is not at all suitable for any purposes, which is totally impure and unsafe to consume. So these are a threshold of our like safety thresholds of our machine learning model, which I set based on research and previous analysis. So this is how my system works, and the entire application is served through the Docker. Now let me show me Docker Hub, where you can access my image. You can just pull this container, just run this command, run the exact command, and replace your API key here in this command, so that your account will get charged and you can get access to a large language model. Now let me just sign into my Docker Hub account. Um, just a minute. Okay. So as you can see, this is my repository, Docker Hub repository, where I push my images. So just go into the AquaGuard AI. Now you can see this is the latest version. You can just pull this container. Just you need to install the Docker application in your computer, or if you're using Linux, you can just install the Docker via sudo commands, and you can just use this command, Docker pull my repository account name, username, and the image name. You can just download it, and once it is downloaded, you can just check it like Docker images. See, once you pulled my Docker image, you will get your it is just added to your Docker local machine. Then once it is added, you can just use this Docker run command. You can use this Docker run command to run this model. right? Then, yeah, this is my project, and I hope this project will be helpful for a non-technical person to measure the water quality and utilizing artificial intelligence and machine learning for effective analysis of the water quality monitoring. Thank you.